Sean? Sean, I was just thinking, hopefully you can hear me here. Waiting for Tangent Stream. It says I'm live. Okay. But there's always a delay, so I never know. But actually, my friend Sean is in the chat, and he was here when I did this years ago. Sean, I was just thinking, I did, hopefully there's a game system for like a programming course on Reddit. As I'm live. Okay. But there's always a delay, so I never know. And this guy was going to do a course. My friend Sean is in the chat. He was here when I did this years ago. Sean, I was just thinking, my friend is a graphic. There was a game 3D artist for like a programming course on Reddit. And so there's always a delay. To kind of like make some videos on YouTube. The first friend Sean YouTube videos I ever posted here when I did this, but I've taken them down. Sean, I was just thinking, my friend is a graphic. There was a game 3D artist for they were they started with Reddit, and so there's always a delay to kind of like make some videos on YouTube. The first YouTube videos I ever posted. Apparently I have a bot that I forgot I sent down. Sean, I was just thinking, there's a graphic. There's a game all 3D artists for I don't know how to turn that on. They started with Reddit, and so there's always a delay to kind of make some videos on YouTube. The first YouTube videos I ever posted. Apparently I have a bot that I forgot I sent down. Sean, I was just thinking, one of the first demos I did. Don't use all 3D artists to make this. I don't know how to turn that on. They started with Reddit, and so there's always a delay. I made a processing version and make some videos on YouTube. Videos I apparently I have a bot that I forgot I sent down. One of the first demos I did. Don't use all 3D artists to make this. I don't know how to turn that on. They started made it years ago. It did not have these little. There's always I made a processing version around all the characters. Make some around all the YouTube. That was the basic idea. YouTube videos I apparently also a lot bigger on the screen. One of the first demos I did. Space all caps. Make this. I don't know how to turn that on. Started made it years ago. It did not built up to this. There's always I never actually made a videos around all the characters. Make some around all the videos. Basic idea. YouTube videos I apparently also a lot bigger on the screen. Anyway, so tonight I'm going to do something a little bit different. I've been working on this for a couple of days. I don't know how to turn that on. Started made it years ago and built up to this. There's always I never actually made videos around all the characters. And I ramble a little bit. Also a lot bigger on the screen. Anyway, so tonight I've been fighting with myself and working between like whether or not I'm going to edit videos and start and Twitch forever. Never actually made videos and I would do that, ramble a little bit, just like film it, and the intent was always to take the recording, edit it, and put it up on YouTube. I've been fighting with myself. I've never done that. Between like whether or not I'm going to edit videos. I did that like I did it a year, 2 years forever. Never actually made originals and passed around. I have like tons of video. I would do that on Twitch, and they just like film it, and the intent was always to take the recording, edit it, and put it up on YouTube. I'm fighting with myself. I've never done that. Between like whether or not I'm going to edit videos. I did that like I did it also some 2 years ago. A friend of mine suggested and passed around. I have like tons of video. I would do that on Twitch, and they just overlap. The intent was always to take the recording, edit it. Something's coming out of my audio. That's new. I must have this channel open somewhere. Oh, I do. Oh, no, that's not it. It's this one. Okay. I have it. Okay. Yep. Thanks. Okay, hopefully that's... Yeah, okay. So I was I was playing I had the tab open, and I have this set to play my desktop audio, which is silly. It's never done that before because I've just never done that. Anyway, I was rambling about something. Basically, the idea was that I'm not going to tell the whole story again because it was not a great story. But anyway, I've been streaming live, and I don't edit. And it occurred to me that rather than trying to edit, I could just work for a couple hours and do whatever I'm working on, and then like at the end just make a 10-minute summary about what I did and just record that as a separate video. So that's what I'm going to do tonight. It's an experiment. We're going to try it. Or I'm going to try it. So, since I have this basic stuff, I've got a bunch of like to-do items, but I really wanted to make like a scripted animation now. And I want to do, I found an animation in, this is a language called Smalltalk here, and or a Pharaoh Smalltalk, and it uses, has its own little graphic system. In fact, it has two graphic systems. This is one graphic library here, and then there's this other interface here. I'm much more partial to this one, but this one comes with an awesome, really awesome visualization system I'm about to load up and demonstrate. And there is an example in here that's very similar to an animation I want to make. And so I was thinking I would maybe try and port this over to this system, which is the one I've been working in. And so I start with the code. I got to find it first, so you get to see all the animations. This is it. So I've got a script for a video about a data structure, and by the way, I'm going to be doing this for like hours, so if you won't hurt my feelings if you drop out. But I want to take this video, this little animation, and convert it over to the other thing. So maybe not this exact animation, but I do want to. But the thing I want is, maybe I should draw it first. I do have a little tablet that I can draw on, if it works. See, the thought was, in the future, I will have, maybe I'll try drawing it with this thing. So if I do just GS app new, and I run this, new scene, I don't even need to print this here. GS sketch scene new. If I run this, then I can double click. Okay, well, that doesn't work the way I expect it to work. How about scene app equals this? If this doesn't work, I'm just going to do something else. And then new scene app make sketch. This is very much a work in progress. What's supposed to happen is when I click on here, it's supposed to make these little rectangles that you can then drag around. Yeah, so the idea that I want to make, or the general idea, is that I want to be able to draw something with a tool like this, and then, excuse me, 1 second. I want to be able to draw something with a tool like this, and then, like, you know, arrange things the way I want them, select them, and move them in places, and then, you know, like draw lines and stuff between them. So, and the other thought is that, you know, I want to be able to mix the creation of sketches like this and then code, so that I can say, okay, well, I drew a picture, now I want to animate it. I want to add some code to it. So this is very early days. It doesn't work yet, other than, you know, what you saw with like the bullets flying around. But with this system, you can do that. You have live objects just living in memory, and then you can interact with them and draw them in different places and do all kinds of neat things like that. So, whoops, I wanted to click this one. So this shows me all the code for this GS app thing. Actually surprised, yeah, GS overlap demo. So like here's the scene, this scene right here, and then you can dig into it and find all the stuff. You can find all the details about whatever you're looking at. All right, so for tonight, I want to make a animation, and I want to talk about how it was made. So for my short video, that's what I'm shooting for. And also, by the way, if you're interested in this and you don't want to watch the whole process of making something, I'm talking to anybody who's watching this in the future. There will be a short video that like summarizes all this. So you're getting the live coding experience here. Okay, so this is the part where I don't know what I'm doing, right? So, okay, so I need to draw some lines between all these boxes. I want to put a bunch of boxes in the scene and then draw lines between them. So I think what I want to do is I want to make a new class that is a demo, and I'm going to call it something like, let's call it GS. I have to spell the word. I'm going to call it a pathmap demo. I was going to call it an ahnentafel, but I'm actually writing a whole song about how you don't want to call it an ahnentafel. So create a class, GS pathmap. This is a data structure that is basically a way of storing a tree in an array or a graph in an array. So this is in game sketchlib. Okay. And do I need any slots, nodes? I don't think I do. I don't think it has any slots. It's just going to be a subclass of GS app. Probably it should be a subclass of GS sketch scene, but I don't. It's not easy to just draw a sketch scene right now. So you need the app anyway. So I'm just going to make it an app. Okay, so make that. Now I have my class. I filled out this little form. Oh no, it's this one. I click this, filled out my little form. Now I have this class, and hopefully when I run this, it puts this over here. So now I have a GS pathmap demo. And if I refresh this, it should draw the GS pathmap demo, and it's empty. And that's what I expect. Okay, and then I'm going to make a method here that's called make start scene. And I'm going to return, let's see. So I have a local variable named S. S is going to be my head's in the way, isn't it? I'll do it like this. I'll use this one. I'll put it over here. I just lost it. No, I didn't. And S is going to be a make, is going to be self. Make sketch scene. I'll make an empty scene. We'll make an empty scene. Okay. And then we're going to return S. Right? And then when we run this, we should just get the same empty scene that we've been seeing. And now let's do something with it. Let's make a same thing I did with the boxes yesterday. I'm going to just draw a bunch of, so 1, 2, 1, 2. I think you have to have you have to have like a power of 2. So let's do 1 to 8. We'll do 1 to 16. And then we're going to say do. Actually, you can put that all into one little phrase. 1 to 16 do, and then s add child, and then self make node. I don't have a make node. Oh, because the I'll copy that from the other system. Now I have some refactoring to do. This is very early days, and I have not put a lot of design into these demos here. So how do I find it? I would just say GS sketch scene, and if I hit Control B to browse that, and then if I click, then it makes this. But if I want a new tab up here, I'm going to Control click this. Now I have a new tab, and I'm going to plot it. All right, because it has all the color collision stuff in it. I'm just going to copy everything. Copy and paste coding. That's great. All right, so we're going to make a new method called make node on this one, and we're going to do it in a different way. Realize there's some duplication here. All right, so we have a variable called node, which I didn't copy for some reason, and at the very end, reason I can't see that. Okay. Undeclared temp. Okay, current. Yeah, this is gonna have to refactor quite a bit here. But also, I mean, refactor because got messy stuff between the two. It's messy in general, and now I'm copying the mess. All right, so I'm gonna make my. Oh, I made my head small, but then I didn't. I'm in studio mode. Okay. Self children, that should be fine. Message is not implemented. Oh, I see, because this is now self seen. Okay, so we don't need PS sketching. So now add child self make node, and if I run this, if I save this and run this, I would expect to see 16 squares right here that are all in one spot. So let's change this a little bit. First of all, let's get rid of all this collision detection. So that's this thing. None of that matters for this demo. And then probably do want a current node. And then the idea here was you double click on one of them, they change a random color. It's not really important. So let's get rid of that. I don't need a current node. This is just a flat animation. All right, so let's get rid of that. And now why isn't that? Because now I didn't use the word current, so we can get rid of that. Oh, but I did need the oh wait. Okay, so here's where I do the 16 of them, and here now they're just gonna be squares, and let's make them that's 75 by 45. Let's just make them 32 by 32. Everything is a power of 2 with me. All right, so now we should have, let's make them random colors. And they're all going to be in the same spot, so. Now we need to change that. And also, so one thing I can do is for so we'll call it row. And we'll say, first of all, S is, and then we add a thing called row, and then we'll say row equals BR horizontal flows or horizontal pane, I guess. I think it is. Yeah, because there's a vertical pane here. New, and then we say row fit content, and then I think we have to add this, and then we say s add row, add colon row. If we do this, then either they're going to all span out here, or they're going to all be in like 0 pixels wide. Let's see what happens. Oh, add child. I got an error. Add row. Oh, I should have fixed that in line. Do it just to be fancy. Add child. So I should be able to save that right in the debugger and run. And now they all added out. Whatever. And then in the bullet demo, I did something like that. Bullet demo. And there was a way to make it cell spacing. You can add a cell space. So let's add. I wonder if you just say, I wonder if you have to say it before or after, whatever. I did it before earlier. See. Interesting. Okay. Right, so it doesn't matter when you do it. All right, and then when you send 2 messages, something you don't have to say row both times, so you can just put a semicolon in there. All right, so that's my make start scene. And actually, we'll call this, I'll actually tell it to relocate to 0 at 5. And that'll give it some space at the top as well. Okay. And I'm going to give these a number as well. So let's make node, and we'll give it an I, a number. That's a small talky thing to do, is have a number on it, and then or is to say a number instead of just like X or something. And we're going to say add child BL roped text element. Is that what it's called? BL text element. BL text element new. Text is a number as roped text. And semicolon. And I believe if I run that now, I'll get numbers on these things. Oh, it does not. Self make node. Oh, now that I added this colon here, it's treating this as one message here. Add child make node. I need to put friends around it, and then run again. And then they have these things, and then then they have numbers, and I can tell it. Trying to do this from memory. I don't remember how to do it. How to make them centered, like text align center maybe. I think it's align. I think it's on the pane. Nope, I don't know how it is. So I will go to my previous demo. Probably in here. I don't know why I always look for it right here, like, because this will have actually GSL has it. Oh yeah, GSL. I could just have it add a GSL new. In fact, that's what I want. The whole point of a GSL is that it's it does exactly this, exactly what I'm doing right now. So instead of self make node, we'll just say GSL new for I. I believe that's right, even though it's just not implemented. Right there. Oh, GSL 4. You don't say new 4, you just say 4. Maybe that's bad design. Get rid of the word new. GSL for I. And now I think that'll just put the numbers in. Nope, it does not. Not understand has parent. GSL for I as elements. There we go. They're not colored anymore, but that's fine. Okay. So for this particular data structure, there's like two variations, and sometimes you want the numbers in one it's the two variations are whether or not you want the number to start with 1 or 0. And I think I want them to start with 0. If I do that, I get this. Okay. I was only making them different colors anyway, just so I could drag them around. And these should be draggable. Nope, they're not. Okay, so how about C equals, how about element? So we need to make a local variable. This little structure right here in the brackets defines a local function, the parameter called I. And then the colon I is just saying there's a parameter called I. This ends the list of parameters. This starts a list of local variables, the pipe here. And so there's a local variable called C. And C is going to be this cell. And as an element, and we're going to say C get C background is color random. Again, not because it's important, just because I was doing a second ago. And we're going to just save this, run this, and it should be random color. Yeah, there they are. And then we can say C add event handler BL pull handler new. I think that's right. And I don't even need this anymore, do I? Because I got rid of make node, so we can just read it. All right, and so then we run this. There we go. Now we should be able to. Oh, I think they were already. I think they already have this, but because they're in a they're in the horizontal pane, then you can't move them around anymore. So I don't actually want the horizontal pane. I want this thing. I want this graph layout thing. So I don't entirely know how to do this. We're going to look for this thing called Mondrian. Mondrian is the layout engine. So we have Mondrian layout examples. This is a class that has examples in it. So I'm going to look at that. And I'm just going to run the example. And click this, run, and see which one of them look like they have output. These are all just Mondrians. Okay, so they don't, I don't think these are visible things. Maybe they are. Oh, they are, okay. So that's a visual component. All right, so let's find one that looks like the one I want. Actually, these up here look exactly like what I want. Which one was it? Maybe I'm not seeing it. Let's just read them. Let's just read the code. Okay, so we make a Mondrian. And then we have nodes, and then we shape, and then we layout custom. Oh, okay. So it's just a container. So GT Mondrian is a. If I click on meta, I get the information about this class, and if I click on this, I can see. If I click on class hierarchy, then it's just. Oh wait, no. I'm looking at GT example with result. I want to look at the Mondrian. So result is this. In fact, nope. How do you get the actual result as an object? Example and result. Okay, that's what I want. I think that's what I want. Value. Okay, so this is what I want right here. So the result is the result of running the test. I want this. I want the value of the test. And if I inspect this, then I see it's a subclass of object. Okay, so it's as element. Self root removed from parent. So if I get a I see. So you put it into the Mondrian. It does the layout. It's called Mondrian because it's all just like boxes and lines. After the painter, and then it removes it from the parent. So it's actually giving back. It's not converting itself into a Mondrian. It's discarding the layout engine and just giving you back this, because it gives me back a canvasable element, whatever that is. So it just gives you back the root of the system, I guess. And then you've lost the ability to lay things out, which is what I want. I want to lay things out and then discard the layout engine. Oh, it does have a bunch of stuff still in it. Okay, whatever. But this is basically what I want. So the answer is what we actually do. If I can find the code. So we make a new Mondrian and then lay it out and then ask for the element, convert it to an element. So let's try that. I copied all that. Actually, I don't know why I don't copy the variable name. All right, so I'm just going to paste this in as an example. So make graph. And it looks like it's just using like just numbers to make the graph, which is actually very close to what I want. Oh, I can't just do this. Actually, what I can do here is I can say, I wonder if I can just say, just ignore all this for a second and just say return self make graph as element. And that is basically commenting out all this stuff. Unreachable code. Yeah, I know it's unreachable. Oh, because this is, I don't need this. All right, and so now when I run it, I get that demo. Okay. And right, so this, okay, so code here, it says mondrian new. Here's the shape. Where's the end of this block? Right here. Width 1 to 5. Okay, so this is where it says BL element new. All this is the same thing I'm doing here with this, except I'm saying row add something, right? So let's copy this. Let's take this out. This in here. Color random. So we actually don't even need this. We just need, we're just going to return oops, GSL for I-1 as an element, and then set the background to some color random. And I think that works, and it'll have the number in it. I think if I just click check on this, and mad about this, so let's get rid of this. Second, no, I'm just delete this. And we don't need this, we don't need this, we don't need this. Yeah, so this is exactly what we need. That's all we need. Say, make graph as element. So when I run this, yeah, that's what I expected. I still have my GSLs as elements with random colors. I really like this engine because you can like make whatever you want, and then like the layout engines all work with it. You could put text, you could put images, you could put anything you want, because everything is the principle is that it's one rendering tree. So it's not like in like a web browser where you have like something. I mean, you can have different kinds of elements, but it's not like you switch to a whole different rendering engine when you start doing a canvas or something like that, or the text versus SVG. HTML is very close to that concept, but in the important ways where it matters, when you start talking about SVG and stuff, it's just not as easy to lay things out. Like the way you position things in text is with CSS, and you have like left and right, and in SVG you've got X and Y, and it's like sorry, left and top, and then X and Y. It's very different. All right, so these numbers are going to be different now. So I want with 1 to 8, and I believe if I do that, we're going to get some nodes that are not connected to anything, right? Yes, that's right. I'm going to get rid of this color random, color white. How about background GS color? I like this gold color for some reason. Okay, so I want to put, right, maybe I put in just 0 to 8, 0 to 7, and then instead of I-1, we just say I. And then, all right, so now I need to look up how this works. Again, we're building up to this kind of, it won't be this, but it'll be like this same kind of style, I guess. So let me find something. So an ahnentafel is a document that shows your ancestors. Really handy if you're like an evil dictator who wants to exterminate a whole group of people and make sure they're the right ethnicity. So that's why I hate the name of this data structure, but that's what people call it. And so when you look it up on Wikipedia, that's where you have to look. I much prefer the name pathmap. And I mean, that wasn't the intent of this thing, but it really was, and it was made for rich European people to like document their their direct ancestors, right? So it's like a family tree, but it only shows your father, mother, direct. There's no sisters or cousins or anything. It's only direct ancestors. Right. So, but what's the actual numbering? I don't know who that is, but I'm going to turn that off. I can't see my phone for some reason. I can't. I've got a problem with my phone. I can't see it. All right, so this is this picture I'm trying to draw. This is the exact picture I'm trying to draw. Although there should be one more thing on it. All right, so we'll just start with 0, right? And the notion here is that I'm just going to copy this picture. So let me just double check that it's right. So the idea is that there's a polynomial. Yeah, you say 2i and 2i plus 1. So 0 goes to 0 has 2 children. 0 is 2. 0 goes to 2, and 0 goes to 2. Right. So you double it. Wait, what? With a 1 index to it. That's why that's why I said it's confusing. So it's 2i plus 1 and 2i plus 2. So 0 goes to 1 and 2. 1 goes to, you double it, and then you add, so it would go to, you double it, and then you add 1, so it goes to 3 and 4, and it does. So those are the lines that you're seeing. All right, so I'm going to put that in Mondrian here. So it looks like, so this is the command. If you highlight this, you see it's connect from to. So I think we just, I could write this map again. I could say 0 goes to whatever. But what it should be is, I think, 0 to 7, and then we say so yeah. So if you send the message value to an object, it sends back itself. So this is like saying value here, I believe, is the same as saying, like, for some x, just return x, right? I think that's the same thing. From value to, and then so here we're going to put that formula in. So x goes to 2 times x plus 1. So let's actually give this a name. So let's say range. So range, and we're going to say range is going to be 0 to 7. And then with range, we'll just say this with range. And then mondrian edges connect range. We would call it x's if we want. I think I can hit Control R and say x's. So 2x plus 1. Oops. And then we add the other edge, which is 2x plus 2. I think this works. And then run it. Yeah, so 0 goes to 1 and 2. 2 goes to 5 and 6. 1 goes to 3 and 4. 3 goes to 7. I really did expect that to be a power of 2, but no, it goes to 6, huh? Should be 1 less than a power of 2. That's right. So there's 7 nodes here, and then if we have, yeah, so let's just confirm that. So if we have, so we'd say 1 to 15, and then we say 1 to 14. So there'd be 15 of them in there. And if I change that number, I should get the same layout, but yeah, exactly. But now it's perfectly balanced. It's 1 less than a power of 2 for an interesting, because it's like if you think about writing a number in binary, you've got 1 here, you've got 2 here, you got 4 here, you got 8 here. So it's 8 plus 4 plus 2 plus 1, which is in binary is going to be 2b. It's going to, well, in Smalltalk, it's going to be 2r. So that's radix 2, meaning in binary, and it's going to be so going left, from the bottom up, you have 1 for the one node in this slot, 2 nodes in this slot, 4 nodes in this slot, and 8 nodes in that slot. So it's just a set of 1s, right? And then you add 1 to it, and then it would be 1 0 0 0 0, and that's the next power of 2. So the number of nodes is 1 less than a power of 2. It would be like if you had, right, and you could do the same thing with. No, you can't. I was going to say, could you do the same thing with 9? Because if you had multiple, you can do the same thing for a. All right, how would you do it? 1 2 3 3 3 3. So you can do the same thing, trinary, right? And then this would be, how do I do a power of 2? I just do 3 to the 3rd power. If I do this and I just print and hit Control P to print it. Oh. Do this. That does not seem to be valid. 27. So it's 3 to the power of something. So 3 to the power of 3. And then if we say 3x1, yeah, so. And then we run this. Yeah, so the same thing should happen. There. But it needs to be 1 less than a power of 3. Oh, so you're right. So it should be 3 to the 3rd minus 1, right? So minus 1. So really we have like depth. And what's the term for degree? The degree of a node is how many branches it has coming out of it. So degree equals, we'll say 3 in this case, and we'll say depth or height, it doesn't matter, of the tree is going to be, say 3. And we'll say degree to the, we'll call it height. I think height is already used in the drawing library, so we'll call it depth. Degree to the depth minus 1, and then here we'll call this degree. Oh, and I have to use degree times x. Yeah, that's right. I can't tell if that's, let's make them slightly smaller. No, I can't. I can't just set the size of those things. Maybe I can. As element size 5 by 5. Maybe I can. I don't know if it was. works or not, because it's like a nested thing. It does, okay. It should be less than a power of 3, right? Change it to 2. Gotta hit this, and then oh, because yeah, I was trying to say this for the 9 case, right? Because it's not 1 plus 1 plus 1 now. It's 1 plus 3 plus 9. 1 plus 3 plus 9. They each have 3 children, and it should be 1 on the top, then 3 plus 9. So that's it's 3 plus 9. So I'm not sure why that works so well for binary. Why that trick with the numbers works so well for binary. So what's 1 plus 3 plus 9, right? That's 1 plus 3 plus 9 would be 13. 13 plus, and then the next higher up is 27. So the next higher power of 3 is 27. So 27. I know how to calculate this. It would be so easy to write this in J. I don't know. It's harder to think. Like, so in J, I would say, so I would say the sum of depth to the degree, right? No, degree to the depth. Like that's how you would write this in J. In J, number of nodes, num nodes equals this in J. All right, so I guess here you would say here you would say 0 to, and then right, so we want the number of items, right? So 0 to I'm sorry, I say degree. It's not that. It's okay, so yeah, so we say I dot depth. So if it's 3 layers deep, then you want 1 plus 2 plus 4, right? Which is 2 to the 0 plus 2 to the 1 plus 2 to the 4. Right? I should bring up J. Come on. Oh, that's not the right J. The old version of J. 1 second. Here we go. All right, so then we say, yeah, so make this bigger. We're saying 2, or so we're saying I 3 or whatever. So that's that. And then we want 2 to those numbers, and then we want to sum them. And if we want the running total, we at each, like, one of the right. This would be like if you the totals if you chopped off the These are all 1 less than a power of 2. But if you do it with 3, I know so I can write this in Smalltalk. So this would be 0 to depth minus 1 collect and then for each one of those we'd say degree to that power and then probably sum it. I bet that's what that is. Maybe this. Maybe you have to wrap that in friends. So I bet if I put this in the scratch over here, I don't need to scratch. I didn't need to make this method. I can just pull this up, and then I have a little thing here. Variable is right. It's not I colon. It's colon I, and then you need a this after it. Does not understand. Depth minus 1. Why not? Because it's all right. So we'll just say 3. No, wait. Yeah. First of all, let's just do it like this. 1, 2, 4. That's what I'm expecting. And then you add those together with sum, right? That's 7. And then so if you change that to 3, 13. And without the sum, this 139. And if we say 7, boom, then that should be the same sequence of numbers that I just did a second ago in J. Not. What did I do wrong? 3 to the I. Oh, because that's not a running sum. This would be this would just be 3 to the I. Which looks, yeah, that's the same. Okay, and then we sum them, we get the last number in that list. 729. Or, no, sorry, we would get 1093 if everything's right? Yeah. I feel like there's probably a closed form for this. So when I see that, I'm going to open up the online encyclopedia of integer sequences.org. And I'm going to paste that number in. Powers of 3. Yes, but I want the sums. Sorry, I wanted this one, right? This is what I meant. 3 to the n minus 1 divided by 2. Okay, and if we do 4, to the n minus 1 divided by 3. Oh, and that's why it's 2 to the n minus 1 divided by 1. And it's just 2 to the n minus 1. Right. So that's the pattern. It's okay. So that's the closed form. Okay, so then the closed form is depth to the degree to the depth divided by degree minus 1. Degree to the depth divided by depth minus 1 or degree minus 1. degree minus 1. Degree minus 1. Okay, so we run that now. Oh, that didn't quite work. Depth minus 1, what it should be. Depth minus 1. Degree to the depth minus 1 minus degree minus 1. Oh, divided by degree minus 1. And Smalltalk goes left to right, so this is evaluates this. You know, first it evaluates this, then it evaluates this, then it says divide, and then it divides it by this. So if I save that, I believe that's going to be good. Clearly not correct. Degree is 3, depth should be 2. So what did I do wrong? Oh, I wanted to do it this way. I wanted to do it this way. It's degree to the, not to the depth minus 1, but degree to the depth minus 1. That's not, this is completely random, but what's it called? Dreambird. Dreambird language. You got to read this. This guy's got a YouTube channel that is so crazy. Far more entertaining than my channel. This is the perfect programming language. You should read the README for this. Dreambird. One of the things it does in this language is it's white space. Has white space. Dreambird has significant white space. Use spacing to specify the order of arithmetic operations. So this gives you 7 because it's 2 times 3 plus 1. And this gives you 9 because it's 1 plus 2 times 3. So it's 3 times 3. I thought that was great. This whole thing is just awesome. You should definitely read it if you are a programmer and you like funny things. And then watch his videos because he's a weird person. I was very impressed. So that's my endorsement for today. Anyway, as I was doing that, I was saying like this is what I want. Right, so, but Smalltalk does this in this order anyway. So this is what I want. All right, so we do that, and we run it, and now we should see. Oh. And that's because I'm saying 0 to that. So I actually need another minus 1. You know, I'm gonna Smalltalk is 1 based anyway. So I'm gonna just say 1 to that and take it off this side, and then I'm gonna change this to 0, 1, and 2. Oh. So 0 to degree, no, I don't need the parentheses. 0 to degree minus 1 do. And now with this number n, or we'll call it I. Right, so we can get rid of this. Right, so now we're going to say, oh, did that work? Yeah, that worked. We're going to say mondrian edges connect. X's from value to then degree times x plus 1 plus I. So now we do all the layers. Should I just put it on one line? That's a little weird place to break the line. Value to connect. How about we say connect? That's why I do that. This doesn't matter. Mondrian edges. How about we say edges? Put the edges here. Break edges onto the next line. Edges connect x's from value to this. if I run this now, not sure why that's not, that didn't work. One to 4. 1, 2, 3, 4. Okay. X is from value to x degree times x plus I. Degree times x. Let's do it for the case of 2. So degree times 2. That would be 2x plus, is that not right? 2x plus I plus 1, it's this. It's this. I forgot the plus 1. I was going to make, there's a joke about how you, oh. The joke is about how you have off by 1 error. Hang on a second. 2I, right, so if the, for one indexed array, which is what I'm doing here, the implementation is simplified and found 2I and 2I plus 1, which is 2I plus 0 and 2I plus 1. 2I plus 0, so if degree is 2, then from 0 to 1 do this. I disconnect from, so 2 times x plus I, that's right. This is what I expect. This is right. It was right the first time. See ya, thanks for watching. Thanks for hanging out here. All right, there we go. Okay, I don't know why that didn't work. Why doesn't this work? X is from value to x degree. Well, I guess if I evaluate all this, it'll show me what oh. I can't see my phone. There we go. I can't see my phone here. Sometimes when it rings or comes on, I can't see it. So it started going green. And we're missing an edge. Like there should be one more edge here. What if I just say degree? I feel like that's completely wrong, but maybe it's not. Zero to. Like this was working a second ago. This is working for. This works for degree 2. I feel it, and it was working for degree 3, or whatever I was doing earlier was working for degree 3. If I do this step 5, I should see 32 on the bottom. No, I should see 16 on the bottom. Let's make it 1, 2, 3, 4, 5, 6, 7, 8. So this is 16. Next row down is 32. That size is making the text very large, isn't it? Maybe it's not. These are still numbers in here. So what's wrong with doing 3 here? If I do 3 to the 3 and save it. Is this formula wrong? It gives me 13 items, which is what I expect, right? 1 plus 3 plus 9. That's what I expect. That's correct. Right, and then if I just evaluate the well, it's going to be, I'm trying to figure out how I would make this. I guess I would say something like degree times x, degree. What am I doing? Degree x I, right? I'm trying to mirror this shape and just debug, because I'm not. This isn't a bug. This is like I'm using the wrong formula or something. I mean, it's a bug, but it's not. So I really want like collect here. That's what I want. This is. What's wrong with that? I don't see why that's a problem. I feel like I had this exact same error like 2 days ago. Three x plus 0, 3x plus 1, 3x plus 2. Oh, we say, oh, I know what we want to do. We want to say do. No, we want to say collect. And we want to say j, and then we want to say x's collect, and then I. Right? Oh, why is it mad with that? What's wrong with that? Oh, x is collect with that, with a. Oh, I see. It's mad because I'm not assigning it to something. So if I just say x is, let's say y's, right? Is equal to this. That's why it's useless to do collect on range if you're not assigning the collection to something. But it wasn't clear to me that that was what it was complaining about. No, I just want to evaluate this part. So really, I want x in here. I want ji. So how about we just say j and j comma I. I wonder if that makes it. I think that works. I'm not sure. See what it does. Again, this just run this. A point. Okay. So these points should correspond to the. These pairs should correspond to the things I'm trying to visualize. So 0 goes to 1, 2, 3. Oh. So here I called it I. I'm going to call this J. I'm going to match the names so that I'm. I have it backwards? No. Because we're mapping the x's, right? So the x's. Maybe I need to add. I need to say degree times. Degree times I comma j. Right? Yeah. Really what we want is I, and then so the from, and then the to plus j. So really it's the same. Yeah, I don't know why I didn't do that. That's the same format. Degree times I plus j is what I want to do. I want to map from I to there. So that's, and then we're doing that for each in this range, 0 to degree minus 1. Okay. Now when I do that, sorry, it should give me these numbers. But I want to see what these numbers are. I want to see if it's like making extra edges that I'm not seeing. So there are. Control G. Is this right? 1 goes to 3. 1 goes to 4, and 1 goes to 5. No. This is not correct. One should go, so looking at, when you do it in a binary tree, 0 should go to 1 and then 2. It should go to the, so it should go to the next two neighbors. It should go to 0. So 1 should go to 2, 3, and 4. It's this should be J. Okay, sorry, that's right. We're looping through the, yeah, we're looping through. No. The x's are 1 to whatever, right? The x's are 1 to 13, right? And then the y's are, or the y's are what I'm looking at here. 1 to 5. Why is it going to 5? Maybe it has a different polynomial? This is only for binary trees, right? With a one index array, the implementation is simplified with children found at 2i and 2i plus 1. So 1 goes to 2 and 1 goes to 3. And so if you do this with degree 3, 1 should go it leaves a gap. Is that right? I think if you start with number 1, it leaves a gap, right? Because it would go, because how do you get, if you went from 1 to 2, 3, and 4, But what would you do? You'd say like 1 times 3 minus 1? Oh, that's horrible. Is that is that is that is that what it does? If I do it like this, does this do what I want? Almost. That does exactly what I want, except it adds one extra link that I don't want. Yeah, that's horrible. I did not know that. I studied this algorithm a little bit because I wrote a script for this video, and I did not know this. This is weird. All right, so if we do it with 0 minus 1, I think everything works. I think the math checks out. Oh, I'm wrong. No, this looks right, but I did something. I did something's missing. The Oh, I see. Wait, and now you have to add 1, right? So now you say 1 to degree. Is that right? Yes. Okay. So 1 to degree. Yes. Okay, that's right. And I can get rid of this now. When you start with 0, then you have this nice simple formula for it. If this is correct. Yeah, that's exactly right. Wow, I was not expecting that. Like this works. What I was doing works just fine. For degree 2. Right, you put this on here, and this is going to work. Except for this one extra node. Because I started with 0. So right, so the way this was working is correct. Everything works for degree. But the formula gets really weird when you switch to 3. Whereas if you number the nodes from 0, then the formula stays simple, or the algorithm stays very simple. That's weird. Oh, what on earth? What did I do? One to degree, right? I don't know what this was. Oh, I just had a large number and then I screwed it up. Okay, so yeah, this is right. So we say then this algorithm works. Oh, what? That didn't work. Oh, depth 2, yeah. Depth 4. 1, 2, 3, 4. Okay, that's right. So let's put it back at degree 2. a depth for, and that's kind of what I wanted to show. I will we'll make it a little bit bigger. If you do this, you can see how it really starts to fan out, and it gives you a nice binary tree. And then so this line is causing them to shrink. I think if I just make the whole graph now at that size, it'll shrink it down. Yeah, that's what I want. You can see the numbers. Okay, so this is like end of part 1 right now. So the goal is what? What is the goal? The goal is to have, well, first of all, you have a lot fewer numbers on the screen. So let's make this, let's just look at the first like 4 layers, right? Right? And what if I say, okay, what if I don't add the, let's, just don't add these yet. We don't add the edges. How does this lay out? 14. And what do I want to, and how do I make, I want to animate between those two things. Okay, so how do I draw that? How do I put them on the scene on the screen at the same time? I'd have to have 2 copies of the code, right? Or maybe make graph connected, and then we'll say connected if true, and then do this. Connect if true, and then we're going to say BL vertical pane new add child self make graph as element add child. Oh no, but we need to say it's self make graph true as element, and then same thing as with false. But probably the other way around. So BL vertical pane. What's wrong with that? BR vertical pane. It's brick, not block. We save that, and then we want to tell it to fit to parent. No. Constraints. Constraints do C, and then C vertical match parent, C horizontal match parent, capital P and an H. And that should make it the same size. Yeah, there we go. All right, so I want to navigate. I want to translate from this to this. This is like frame 1, and this is frame 0. Frame 0. Frame 0, frame 1. So this is the start frame. This is the end frame. Keyframes, right? So one thing I could do is I can add an animation. Like, you know, I can do this layout. I can just obtain the position for these elements. Okay. So this is actually not the picture I had in my head, right? This is a visualization that I started doing right now. I actually had this picture in my head. This is what I wanted to draw. And to do it that way, I would need to draw curved lines with arrows on them. This avoids that. But then I have to like animate this, right? And then move all 3 of these, you know, here. And there is some kind of like value to that because like you can see we're just picking this thing up and like moving it on top of the, you know, on top of the others at each step. I cannot select them though. Right? What if I say mondrian layout First of all, what if I gave this a name and I add a and I just add a mondrian here? I would say mon. Mo. I'll just M. Mondrian. Oh, mondrian. Mond. We'll call it a mond. Mond. Okay. So, and then we will rename this Control R mon. Okay. And then we don't need y's. We can remove y's. And then because this is a shares the name of a local variable, a class variable, an instance variable. Remove it. So now it's just using the instance variable. We run it again. Same thing should happen here. And then at the end, mon will be this. So what if we say now we say mon layout horizontal and just Control D to do it. I'm expecting this to go into this format like this, but keep the lines intact. But instead, layout was sent to nil. So what is mon? Ooh, horizontal was sent to nil. Right. Sorry. Layout was sent to nil. Okay. So, because I'm looking at, I need to do it on this one. So let's run this. Now we have another, we've updated this one. I just should have done it over here. That's what I should have done. All right, so mon layout, and we inspect that. We get a layout builder. And if I just say horizontal here, run it, now I should do that. Chat disconnect. It did. Okay. On layout. Crap. Oops. On layout. Oh, these are my options. On layout grid. On layout force. On layout dominance tree. Oh, just tree. Same. Horizontal tree. Yeah. One thing I could do is so first I have to make the decision. Do I want to make a tree like this, or do I want to make this? And I think right now this is harder for me because I don't know how to do these lines. What I was originally picturing was I would draw, you know, still do with the numbers with the boxes in here, but then draw like an arc, right, from 0 to 2, and then, you know, like draw these like springing out, and like, you know, animate these lines like coming out and landing in the right place. That's what I was getting at when I was talking about this animation. So if I go back one, right, I was picturing very much, as soon as I click this, we're going to see it, that I was picturing something like this, like where these lines are being drawn. But this is a completely different animation engine, so I could use this as an example to draw it in Rosal here. But it's a completely different graphical stack and a completely different engine. I could dive into the code and figure out how to, you know, use this as a way to help me learn how to draw, you know, do the animation in general. But like, but like, I need to figure out how to animate a scene. Hmm. Okay. So yeah, like I said, it's kind of like the end of part one here. So I'm doing this experiment now where I'm gonna, you know, try and make a summary of this video, and this is like a nice ending animation, right? I would think. Oh, that's actually interesting. Oh, did I crash this thing? Yeah, I think I might have crashed. DL singular matrix there. Okay, so there's a control dot, control period, alt period, Control Shift Alt period. Control period. I don't know what the keyboard is, and I also don't know if it takes my keyboard layout into account. So I have a Dvorak keyboard, and that would suck if it. Oh, I am an Opus null debugging exception. Something came up. Oh man. Okay, well that was really a good stopping point. Yeah. So okay, so it's Control E on my machine, which is Control period. You know, the key says E, but it's a Dvorak layout. Okay. I should be able to recover this from the changes. Oh, actually, am I live? No. Okay. Oh, you just had to hit it one more time, I guess. Now it's fine. Okay. Thought I was gonna have to do everything. All right. So let me. Yeah. What was weird is I had lost this little guy up here, and I thought, I don't know, but I think if I let's do this as a BL horizontal pane. I'm going to put them a new horizontal pane, and then we'll make the graph. We don't need the you know. I added an argument, so then this made a copy. And we don't need this dominated thing, so we're going to say I think I want to say perform which layout. Layout a symbol. Form a symbol. Right? A symbol. Form colon a symbol. And so I should be able to pass in a method name. Do I need make node anymore? This is garbage too. And then I'm going to say vertical match parent. No, it's this one. That's not. Make graph false and layout vertical with a hash mark in front of it. What's wrong with that? Nothing's wrong. It's just freezing up. I loaded a bunch of stuff into this image, and so it's really, and we call this tree, right? Horizontal tree. This message right here. So we pass it this message. Pass it this message. Tree. Boom. And then run it. And then there we go. And then the other thing I'm thinking is I want to remove this button. So I think it's called make UI. And then just say return make start scene. So. Okay. And so I can remove this version without the layout strategy. And then this is indented a little weird for my taste. I actually have a macro that dedents 2 spaces. But it does not do the way. Oh, these are tabs, that's why. Put shape down here. I don't know if this makes sense or not, but with X's, shapes with X's, okay, and then connected. If it's connected, then we're going to do then we're going to add the edges, and then that's it. Then we return the mondrian. And it still works. Okay, so I guess now my thought is I've done all this rambling. I've come to a good stopping point. And so now I'm going to go offline and record or prepare like a really short version of this, record it and upload it. Maybe I do it live, I don't know. But it would be a separate video. So at least I'm going to end this video. So thanks for watching, and let me know what you think of this experiment and of doing 2 different videos, like a short one and a long one, which one you prefer. And if you have any comments or questions about any of this or anything you want me to cover, let me know that in the comments too. So I'm very open to feedback here. Like I have a goal of what I want to make, but if you have, and you know, that's kind of fixed. But if you have ideas or thoughts about the stream or whatever, let me know. So yeah, thanks for watching, and see you again soon.